Okay, good morning. So I'm going to do this tutorial. This is about combined linear and angular motion in hoists, or in a hoist, or simply we could compare this one to a pulley. So if you have here a hoist, actually this is related also to the laboratory activity that I had uploaded already, the moment of inertia on the flywheel. So for example, you have here the direction of your hoist is clockwise direction because, okay, I should say counterclockwise. So there's like a certain object here. It would be like we can say in a lift, in an elevator. So the movement of this is going up. Okay, the movement here is going up. Okay, so that traces up this block. Maybe you have here a certain person, a certain man. Okay, going up. So the movement here is in this direction. Okay, in this motion, in the counterclockwise, this one is moving up. So according to the rule for angular motion in hoist, that if you have this direction, the torque T here is going in counterclockwise direction. So there's always a resistance generated in opposite direction by the frictional couple. Okay, so there is the couple generated by the friction, and then there's also opposing direction generated by the inertia couple. Okay, so if the movement is counterclockwise, it's always an opposite direction for the friction and then the inertia couple. And then there is also this E, this is tension force, and if you are going to convert this one into in angular motion, just have to multiply with R, and that is why you have here the total torque is equal to frictional couple, inertia couple, and then the couple generated by this external force, or E, or the elevator, or the tension, which is just equal to, if we're going to if we're going to get the forces in vertical direction here, so you just have E is equal to W and then MA. Take note that if your direction of your acceleration or the movement is going up, so your acceleration is going up, there's always the reverse effective force that is in opposite direction. Okay, that's why you have your E is equal to MA and then W, by which W is equal to mass and then gravitational acceleration. And take note, if you are going to convert or to get the angular acceleration, it is just equal to linear acceleration and then the radius of this hoist. Okay, and then your moment of inertia in the hoist is also equal to the mass of the hoist and then the radius of gyration. Okay, so let us try to solve this example. Okay, so there is a load of 1,000 kilogram that is to be raised. Okay, so it's going in this direction. Okay, it is to be raised with an acceleration. Here is an acceleration of 1.1. This is 1.1. Okay, meter per second squared. So acceleration is 1.1 meter per second squared. Okay, and then it is lifted up by a certain cable. This one is the cable going up. So this one in this direction clockwise. The diameter of this hoist is equal to 2 meters. Okay, so therefore the radius of the hoist is equal to 1 meter. And then the drum has a mass of this one, mass is equal to 1,000 kilograms. The radius of gyration, K, is equal to 750 millimeter, or we could say it's 0.75 of a meter. Now we are asked to compute what is the torque. Okay, so by that equation we can say torque is just equal to this TF, the frictional couple, and then the moment inertia couple multiplied by the angular acceleration, and then this tension, okay, force multiplied by its radius. Now what is TF? It's given. Is it given? Okay. The frictional couple is not given, so it's 0. Okay, it's understood to be 0 if it's not given. Now, how about the moment of inertia? Moment of inertia is just equal to mk squared. So, what is our mass? 1,000 kilogram. That is the mass of the hoist. The mass of this drum, of this block here is 8,000 kilogram. Okay. So, the mass of this hoist is 1,000 kilogram. K is 0.75 squared. It should be in meter. So, we can have here moment of inertia, okay, will be equal to 562.5 kilogram and then meter squared. So, we have already I. Angular acceleration is just equal to linear acceleration, which is 1.1 meter per second squared, over the radius, which is 1 meter. Okay, so simply you have 1.1 radian per second squared. Okay, so we have already this angular acceleration. We have I. Now, how about E? Okay, E is just equal to MA and then mg. So what is the mass? It's actually A plus G. Okay, we can factor out to make it simple. Mass is equal to 1,000 kilogram. Acceleration is 1.1 meter per second squared, plus gravitational acceleration, which is 9.81 meter per second squared. So E here could be computed. Okay, so what's the value of E? It's just 87,280. Now it's Newton. Kilogram and meter per second squared becomes Newton. Okay, so I think we have all that we need. So we can just substitute again. T, as I said, is equal to frictional force, which is equal to 0. The couple, inertia couple, and then this angular acceleration, and then E multiplied by R. So T, therefore, I we calculated already, okay, earlier. That is, what is the value of our I? 562.5. 562.5. It's here. Okay, I is 562.5 kilogram per, and then meter squared, I should say. Okay, angular acceleration, which is 1.1 radian per second squared, and then E, which we have already, 87,280 kilograms, and then R, our radius, which is equal to 1 meter. Okay, I know this one E is already Newton, sorry. Okay, so torque could just be calculated. Okay, anyway, here kilogram and then over times meter per second squared becomes Newton. So the unit here of this one, when you multiply, that is Newton meter. Meaning when you have kilogram multiplied by meter squared, and then you have second squared, it is just equal to kilogram and then meter per second squared multiplied by meter. So this one is Newton and then meter. So that's why you have here. Okay, so the value is 87.89. Like we just have times 10 to the power of 3 Newton, okay, meter, or we could say 87.89 kilonewton meter. Okay, so that's all for this type of problem, which is all about the angular motion on a hoist. This is a similar or applicable to the laboratory activity that we had on the moment of inertia flywheel. So this kind of problem has the concept on the lift or the elevator. Okay, so watch out for more problems that I'm going to teach to you. Thank you, and see you in the next videos.